So in session 1, Science presented their research work on the potential of fertiliser treatments being applied at mid-rotation to improve productivity. So in this project, we looked at the impact of some of those experimental fertiliser treatments on water quality. We had a look at 3 sites across New Zealand, and we tested a liquid foliar fertiliser treatment with low amounts of nitrogen and phosphorus, and we retained a 10-metre streamside buffer either side of the stream. And we also looked at granular fertiliser applications which contained higher amounts of nitrogen and phosphorus, and on those ones we tested with a 20-metre streamside buffer. In general, the liquid foliar fertiliser applications had minimal impacts on water quality on the day of application. Nutrient concentrations were mainly within background rates for the remainder of the trial period. We found similar results for the granular DAP application, but for the urea, we picked up spikes in nitrogen in the stream water on the day of application, or we would pick up a spike in rainfall events shortly afterwards that were sufficient to initiate drainage. And at one site, we also picked up a spike when there was a resumption of flow after a dry spell. Just looking at the example from Berwick Forest, if you look at the liquid foliar fertiliser graph, you can just see that there was a small increase in nitrogen on the day of application. If you look at urea and you look at the y-axis, and you can see that there's roughly a 10-fold higher increase in the urea spike on the day of application, but it only lasted for several hours. Also take note that at this site that the background concentrations of nitrogen in the water were close to or above the New Zealand guideline for ecosystem health in rivers. So the results from these initial experimental treatments indicate that there were minimal impacts on water quality from foliar and DAP fertiliser treatments and short-term impacts from urea. The experimental stream buffer widths that we tested mediated impacts on water quality to varying degrees. It did highlight the value of undertaking water quality monitoring before fertiliser applications to identify any potential high-risk sites. It's also showing the value of the precise targeted fertiliser applications, which we've heard quite a bit about today, that have the potential to minimise the amount of fertiliser that's applied, and also ways to try and maximise nutrient retention on site. And these have the potential to maintain the good water quality that we normally get from our planted forests.